Is there a business case for Mars? How can the innovations that are going into Mars and the journey there, including the moon, can also benefit humanity? Leading this panel is Steinke, who's the Chief Operating Officer at CisLunar Industries and Interim CEO at Orbital Fab. She has an extraordinary lineup of experience, including as a partner with the U.S. Space Force, where she led the 2022 Space Futures Workshop with industry to explore commercial views on the future of space. So Lee is the perfect person to be moderating this panel. So Lee.
Thank you so much, Chris. Good morning, everyone, and thank you for being here and listening in virtually. We've sent things to Mars. We've landed there. We've generated oxygen there. We've drilled there, sensed there, photographed and recorded sound there, transmitted data to and from there, and we've flown a drone there. In this panel, we'll discuss commercial applications for Mars technologies in Earth markets. I'll introduce our panelists. We'll each have a little bit of time to introduce themselves, and then I'll ask some questions, and finally we'll open the floor for your questions. Dr. Tiffany Vora is a keynote speaker, writer, scientist, and entrepreneur who fosters global conversations about humanity's future. She is faculty and vice chair of medicine and digital biology at Singularity University, a non-resident fellow of the Geotech Center of the Atlantic Council, and faculty at EY Tech University. She's a board member at ExploreMars and an industry advisory board member for Lifespan.io. Tiffany earned her Ph.D. in molecular biology at Princeton University. Welcome, Dr. Vora, and please go ahead with your introductory presentation.
So I have no slides. I like to just talk when we're all together like this. It's a real treat. So thank you everyone for being here as well. So I am a molecular biologist by training. That means my major interest is in biotechnologies. So these days I live in Silicon Valley. I spend my time talking with startups, with government folks, with large established companies about the technologies that they're working on. And so for me, anything that biology and biotechnology touches is something that I'm interested in. And so space, of course, is a big part of that. So I'm really excited to be here today to share with you what I'm seeing in the biotechnology space, what the markets are that I'm seeing as well. We're at a really, really exciting time. I'm looking forward to sharing that with you. And of course, when we're talking about space, bio touches our food, it touches our health, it touches environmental closed loop systems. All of this stuff to me comes back to biology, and I'm a biologist, so I'm biased, but I really believe that if the computer age was the 21st century, the 20th century, then the 21st century is really going to be the biology age.
Right. Some of the science is taking out bias, right? So you're an expert in that too.
Trying.
Thank you, Tiffany. Dr. Eduardo Diaz is founder and CEO of AdvancingX and a renowned psychologist and expert human factors research scientist. He specializes in serving as a principal investigator and co-PI on research that aims to identify how external forces affect the psychological and physiological performance of teams and how they can adjust to these factors. Dr. Diaz earned his doctoral degree and Master's of Science in General Psychology Research and Evaluation from Walden University. He completed his undergraduate studies at Sonoma State University in conjunction with University of California, Berkeley. Thank you for being here, Dr. Ed. You have the floor.
Thank you. My main message to everyone is that you are enough to be an astronaut. And with that, I want to show you a short video, which is not on the screen. So with that, I focus on the team aspect of astronauts working in the commercial space industry, from identifying and selecting them to training them, all the way to monitoring their performance while they're actually working in space. Our whole thing is to mitigate risks and work with individuals that contribute to the entire team. We do not do individual selection and training and say, you go, and then hope that you get along with the people you're going to be working with. So all the things that we do focus on every aspect of research in different extreme environment situations, lava tunnels and things like that. And that's kind of really what I think we've got to take as humanity as we move forward into exploring space like Mars, the moon, and beyond, is the entire human component that is out there. All the equipment and technologies are all fantastic, but the human factors, those components, should be the center focus. So yeah.
Compounding of complexity as you add different personalities, and it's really exciting team. Michael Mealing is a general partner with Starbridge Venture Capital, a venture capital fund focused on the commercial space technology sector. He has extensive experience building solutions for markets that do not yet exist, including some of the internet's basic systems in the early 90s. Starbridge Venture Capital invests in companies whose products will play an important role in developing new commercial space activity, while at the same time having large profit potential in existing markets right here on Earth. Michael was one of the first people I met in the space industry, and shortly after I interviewed him, I called him on the phone and asked him to be my mentor. He said no. He said, I won't be your mentor, you don't need one. Let's collaborate and stay connected. I thought that was a great message, and we have collaborated several times since then, so thank you, Michael.
So yeah, I have been in the space sector since about 2004, when I was one of the original founders at Maston Space Systems with Dave Maston and a small group. So I've seen how hard it is to run a company. And then about 2017, I met up with some recovering hedge fund managers, and apparently there is a 12-step program for that. And we both kind of realized that there were a lot of traditional VCs that really didn't understand our sector, the space sector, and a lot of companies that were not able to raise what we thought would be around because of that. And so we decided that there needed to be a traditional returns focused on returning money to the LP, not on investing in headlines, but somebody that could actually help space startups actually understand how to raise money and how to sell to markets. One of the original things that we talked about was, is Mars technology investable? There's a meme that runs around the internet, with the one astronaut standing behind another one with a gun, and it always has been. When we first started back in 2017, I was at a Spacecom Expo conference down in Houston, and there was a company there called Chemvita Factory. It was one woman. She had just won an SBIR from NASA for being able to produce food on Mars. She had a device that would take CO2, water, and solar energy and produce simple sugars. That's all it did. And if you understand, polysaccharides and things you can do with sugars, a lot of those things become precursors for other things. That company is now one of the leading companies in taking CO2 emissions from refineries and turning them into plastics precursors. And they're now helping refineries take what used to be a waste and turning it into carbon credits and an additional product they can now sell without ever going to Mars. But the technology they still have a small division that is working on space applications for the exact same technology. So yes, if you're solving a problem in space being so hard, odds are you are solving a terrestrial problem as well, but doing it better than anyone else is doing because of the constraints on your problem space. That's part of our thesis, is we invest in things down here that enable things out there. And we feel that, that's a core part of how you make money in this business and how you actually build a sustainable future space exploration program that allows us to get to settlement. Later on, I'm going to ask the audience a question about how many of you actually want to go to Mars. So be thinking about your answer.
I think they might have thought about that before. You want to go ahead and ask it now?
No, you'll be surprised. We'll get into it in a minute.
All right, excellent. Thank you, Michael. Ramon Blanco Maceiras is the head of U.S. Space at AVS Added Value Solutions, leading the strategic expansion of its space division from Europe into the U.S. market. AVS is committed to boosting scientific knowledge and currently spearheads the development of the robotic hand and other crucial systems for NASA's Mars Sample Return mission. Ramon holds a Master's of Science in Propulsion and Engine Systems Engineering from the University of Southampton and a Bachelor of Science in Aerospace Engineering from Delft University of Technology, where he co-led the design of a crewed Mars flyby mission. Ramon, as a relative newcomer to the industry, I've been a fan of AVS only since Yuri's night at IAC in Paris last year. Please give us your introduction.
Thank you very much. So yeah, I will use my time mainly to give you a little bit of a look at what is AVS. I think is probably not many people here in the audience have heard about this company before. And we're a small international company, so born in Spain, have been around for 17 years and now expanded through Europe to the UK and now most recently to the US. As the mission says, boosting scientific knowledge, we like to do the coolest missions and most significant missions in the wider science industry. So this brings us to providing critical equipment to particle accelerators, fusion reactors for the space industry, and also for astronomy. These are some, it's difficult to give, let's say, with words, what does this mean? So these are some pictures of the type of projects that we develop on some of these ground industries. And in space, like for me personally, the story of AVS started surprisingly in Mars. So first flight hardware that the company ever put into space not only went to orbit, but it went to Mars surface. And that was our contributions to two of the instruments which are today rolling around on board Mars Perseverance rover. So it felt like a very nice kind of like moment of commonality joining a company with such a shared vision. For myself personally, the moment that I decided to dedicate myself to the space industry was through university working on a project to design a Mars crewed mission. That was the moment that inspired me to never look back at any other industry. Yeah, for ABS as well is one of our main core interest and areas of development. From this first experience, we managed to get ourselves into the next Mars mission. So here's a little video which showcases as the sample transfer arm on the lander system that will be launched to Mars to retrieve the samples, which will make it back to Earth to get amazing insights. I think this is one of the most exciting missions. May answer the question, has there ever been life or is there still life in Mars? And so all in all, looking at this whole architecture today, we can probably say we have gained quite some experience on our initial contributions for Mars Perseverance, and that allows us to today be working on the robotic hand, or the end effector at the end of the STA, as well as the compliance mechanism, and we also work on the difficult problem of dust mitigation for Mars. We are kind of like going the opposite way. So we first went to Mars. What are our next endeavors? So we're developing technology also for deep space missions. This is landing systems and sampling mechanisms that are able to work in environments of low gravity. This could be like moons or asteroids. next critical system. We've been hearing a lot about all the architectures today. There is no humans to Moon, humans to Mars without in situ resource utilization. So we're probably part of the project led by Thales Alenia Space in Europe, so supported by the European Space Agency, to demonstrate oxygen extraction from lunar regolith. And here, being true to our core knowledge of mechatronics and robotics, we are doing basically most of the systems which deal with the regolith, which have to handle the regolith into the reactor. Next point, which is important, mobility in these complex environments. So we're also part of a project for the European Moon rover, led by a company GMV, also out of Spain, and working to provide kind of like a common mobility platform for different objective missions that European Space Agency is looking at developing on the Moon surface. And finally, of course, we always have to come back to Earth. So our newest development is actually having capability to do small sats, both small sat buses, small sat missions. This is demonstrated with our first mission, which will be Earth observation. But our goal is to use these platforms to be able to go farther than low Earth orbit. So we're making them be able to have high-performance propulsion power systems which are well suited for interplanetary missions. And the first example of a combination of all of these experiences and goals is a very interesting mission concept that we have started to work on with the European Space Agency. It's called Meteomars. It's also, I think, the most relevant experience towards the topic of this panel, bringing it back, which is, how do we see companies making money out of Mars? So there is obviously the spin-off potential, but once there is a drive to go there, once there is a human society, what type of services will be needed? This is one of the ones that we think will be key. So basically providing weather to any robotic mission, any human mission. And we're studying what could be the most cost-effective, most fastest method that we can create basically a meteorological network in Mars, combining our experience with Mars penetrators and with the small satellites to deploy that architecture. And don't be too afraid by this image. This is not the preliminary real concept of the mission. This is actually what an AI image generator has come up when I prompted what would it look like to have some Martian penetrators being deployed across the surface of Mars. So thanks to Midjourney.
How efficient. Thank you, Ramon. I want to ask a follow-up of both you and Michael. Talk about the resources it takes to find terrestrial applications for the technologies that we're developing for space. And so I'll start with Ramon.
Could you say that again? Sorry.
Yes, sorry. So you talk about applications, you have many specific technologies you've addressed. Talk a little bit about how AVS approaches finding terrestrial applications for those, if there's any investment on that side.
Yeah. So for ourselves, obviously, as I said, a lot of the systems, critical systems that we do are related to mechatronics and robotics. And for the industries that we do that, they are all with fairly similar environments and requirements. So our know-how and the technologies that we develop for space many times have a back use towards these type of systems, critical systems that we provide to particle accelerators, synchrotrons, and even fusion reactors. So there is kind of like a circular fit through. Things we learn from those ground industries enables us to more effectively develop new technologies for space, but also sometimes things we learn from developing the technologies in the space make it back to the products we can offer on ground. And also it's kind of useful when you said you've done something which is working in Mars. It gives you a nice stamp of credibility towards any other thing that you want to do on Earth.
Thank you. Michael?
Sure. So one of the things that we look for, and this is really about the companies that we invest in and what they have to go through to find that, it really has nothing really to do with the technology. There are a lot of times when we hear pitches from companies, we ask them to just don't talk about your technology at all because we don't really care at the beginning. What we care about is, have you spent time with a potential customer or customers, preferably, enough that you understand their business well enough to help them solve a problem? And if you have discovered a problem that is large enough that they're willing to throw large amounts of money at you to solve, you've now done the hardest part of building a business, is now you actually have a business model. Then you can determine whether or not you actually have the capability of solving that problem, sometimes with technology, sometimes with not. Where we look at it in terms of the space context is space, like I said, makes you do things at a much more harsh environment and limitations. So you come up with creative solutions to things. But it all comes back to spending a lot of time with the customers and understanding their businesses. The term of art that we use in the investment world is customer discovery. I care more about your customer discovery than pretty much anything else, because in our sector and in most technology sectors, one of the biggest problems we have is companies that are built to scratch a technology itch, not actually solve a business problem. And that's one of the biggest challenges out there. One of the things that we do encourage, and you'll see some of this on our website, starbridgevc.com. If you look there's a section with publications. We have something called a market readiness level. It goes on with TRLs to be able to determine if your TRL is low, but your market readiness level is really high. That makes you very investable. If you got a really high TRL level but a low MRL level, yeah, you're just dealing with technology. One of the things that we strongly encourage entrepreneurs to do is, there's a concept called business model canvas, which is a way of documenting how a company works and how it realizes its value proposition. We encourage entrepreneurs to actually attempt to do the business model canvas on their customers. And then once they think they have the business model canvas, the documentation on how their customer's business works, take it to that customer and ask them, is this how you do business? And this is where I might fit. And that's one of the key things that really, if you understand your customer really well, and that customer knows that you are caring about their problems, not yours, the odds of you closing that sale go up tremendously. And that's really what we focus on. We spend a lot of time on that as opposed to, vetting the technology, doing tech due diligence. That's the easy part. Doing market due diligence is the really hard part.
Thank you, Michael. Dr. Ed, Dr. Tiffany, would you like to bring up a specific technology and talk about the markets for it on Earth? Tiffany.
I'll go first. So just before I do that, I just want to amplify something that I heard from my colleagues here, which is, so when I think about the business trajectory of taking a technology to market, you start with a science problem, it turns into an engineering problem, it turns into a business problem, right? But you can't wait until you're ready to go to market before you start thinking about what business problem you're actually trying to solve. So everything you just heard here, if you are an entrepreneur, I hope you wrote every single thing down, because it's super, super important that we aren't just having a solution in search of a problem, that we're actually moving forward with that problem focus. I think it's a really important part. So now, having said that, I'm going to talk about a technology. Apologies. One area that I'm watching really carefully right now is synthetic biology. You've heard a bits and pieces in various other days here at Humans to Mars, which is great. But synthetic biology is basically the ability to program living things to produce materials or information transfer or energy transfer based on a set of inputs that you use. So we're basically building off of nature's 4 billion years of evolution on this planet in order to come up with the solutions to these big problems that we have. And so you might remember last year, President Biden signed an executive order looking to turbocharge the American bioeconomy. There are several geopolitical considerations that I won't go into here, but there's a geopolitical drive behind the bioeconomy drive today. And the EU, the UK, Germany, and China have all been working hard on their bioeconomy roadmaps. So when I think about Mars in particular, Moon as well, but Mars, the type of resource constraints that we're talking about when we talk about Mars are such that I believe that biology is really the answer here. If we're talking about whether pharmaceuticals are going to make it through a 3-year mission, if you have the capacity to manufacture those on demand, small batch, purification works, all of these things, there are cases in which these biotic solutions are either as good as or potentially superior to abiotic solutions. So from a market potential, the question becomes, how do we identify the places where the biotic solution is actually superior to the abiotic solution? What kind of infrastructure do we need for that? What kind of inputs? I can talk all day about chassis organisms and yeast and CRISPR and all these really amazing things, but you need tanks and you need pipes and you need water and you need energy. You need all of these pieces. And so I think of the biotechnologies and synthetic biology as being kind of a nucleus for where all of these other innovations are going to come together. And just one more piece that I want to come up with here and tout as a major benefit of synthetic biology is we're talking about a platform rather than a single product per se. So if we have the capacity to build these platforms that can maybe be deployed against a variety of problems, potentially even problems that we haven't identified yet as being the problem. So I've done 3 analog Mars missions, and I can tell you that there are the problems you know about, and then there are the problems that happen. And what we really need are a series of solutions that have that nimbleness and that robustness. And I think biotechnology is right up there as the place where we're going to get a lot of that value.
Wow.
Your turn.
Education and inspiration from the grand scheme of things. Imagine if you were working in just a small city and there was no space exploration, and you're in this small city working with teams of people to develop some type of technology, and then you ultimately bring that to market if all goes well. That's cool for the city, but because we are working in space, the opportunity, it has a global impact, and it inspires on a global level, and it gives others around the world who see what's going on, who become aware of what's going on, an opportunity to dream and to visualize something from their lens of life experiences. And from that comes development, ingenuity, entrepreneurship. The space industry is a huge vehicle to inspire us to do more. And so education is where all this really translates down to everyone. There's no doors here that says you have to unlock it. Just look up anywhere in the world. There's a technology that NASA developed with AI, back to don't freak out, but I could have a long dialogue about AI, but specifically called human-machine teaming, HMT. And our company licensed HMT to complement what we're doing in the world of optimal team design, OTD. So that's working with teams to train them to work in a microgravity environment, lunar gravity, Mars gravity, things like that, atmospheres, whatever have you. HMT is a way to combine a technology like a hardware or a machine with the operator who's controlling that machine. And it improves the performance of, well, technically both. The autonomous machine that still needs input from a human perspective, and the human themselves, the operator, in terms of how efficient can they be in managing multiple machines out there, drones, rovers, mining tools. How efficient can they really be? And this HMT technology provides that opportunity when we understand the entire team dynamic. So all this stuff helps in terms of companies on Earth that are looking to advance not only their technologies, but back to the human component, how is this going to be operated by different operators, and and how many machines can they operate, which is a really fantastic research question that we're working on. Instead of guessing, like we know you can operate 2 farming pieces of equipment. Well, did you do the research on it? No, they don't. They just look, it looks great. You're doing a fantastic job. But HMT will enable us to see that maybe it's 6 or 7 of these 40 million, that's 40,000, these $40 million pieces of equipment, well, maybe they can manage 6, in which case you've actually reduced the cost of human operation, and you've improved or increased the output of the machines and their ability to work. So all these things come together. It's a complete collaboration, working with different partners, which again goes back to education, right? Where all these different agencies, organizations, entrepreneurs, global impact, we all have an opportunity to collaborate and unite. That's where I see the translation.
Yeah, the evolution of human-machine interfaces over the last decade has been incredible, and I think that will be a continued market.
Can I amplify
Yes,
something
please,
here?
yes.
So I think you've got a really important point here, and I want to make sure we really, really put a pin in it, which is that we're not talking about technologies or markets for replacing humans, right? This is all about human-centered technology. We often, when we talk about Mars, it's humans or robots. Who should we send? That's a false choice, right? We need humans and robots, humans and algorithms. And as we look at the market now, again, a lot of the conversation is about, are the robots going to take my job? That's not the question we need to be asking. That's not the business question either. The business question is, how are we using robots and algorithms and technology to improve human performance as teams, as individuals, as organizations, or, again, coming from me for the healthcare sector, right? Like, for me, tech in healthcare is about putting the human back in the healthcare relationship, making sure doctors aren't just checking lists. We had a great comment yesterday in a panel about using ambient technology, digital biomarkers to be able to monitor astronaut health. That's really great, because then when I'm talking with my doctor, she's looking me in the eyes instead of having her fingers on the keyboard, right? This is what I want. So when we're looking at that trajectory to get to Mars, which if we aren't seeing humans on Mars for 10 years, these are the market opportunities that I'm keeping my eyes open for as I'm watching this technology roll out. Because in 10 years, by the time we get there, we feel like we're having an AI moment now. My hope is that in 10 years, AI is boring. So boring that we don't even notice it. So the business opportunity is make AI boring. There you go. That's my challenge to all of you.
If you don't
Yeah,
mind,
go
I'm
ahead.
gonna riff on this with an actual company right now.
Yeah.
Because yes, we're talking about, for the most cases, the AI and the machine aspect of it are augmenting. But there are things that humans now are becoming to the point where they can't do. And that actually really does apply in space a lot more. One of the things that we've become aware of through a company called Off-World AI, swarm robotic mining, but really swarm robotics in a general case. A lot of different applications. They have a space component, but really is about mining right now. And one of the things that we've learned is all of the easily accessible by humans ore bodies have been exhausted. If you need copper, you're going to have to go to places either that are 200 degrees and high pressure, highly tectonic, where you get rock falls all the time and you kill people on a regular basis, or they're in places that we've decided we don't want to tear down the entire Andes to be able to get access to these things. And we're getting to the point where, for example, one of the things that always bugged me about the Expanse was you're actually using human beings to do mining? The most expensive, fragile, ornery thing that you could possibly send to space to be able to do the work when you've got all these robots that can do it just fine. So yeah, we're amplifying both the individual in a lot of cases, but we're amplifying our total ability to do things that currently are not possible for human beings to do at all. And so there's a lot of places here on Earth where we're doing that machine to human, because at least in Off-World's case, it's human-guided. So you imagine one person managing a swarm. That's really amplifying a human's capability, and it's space that makes you do that. It's space that makes you think that way. And then applying it down to Earth means we're actually not running out of resources if we do it right. So.
Yeah,
To add to that,
Go ahead.
I love this conversation. To add to that, when you have that human component still involved in, like the mining operation is the example, and you have the cameras or sensors that are observing whatever the machine is working on. Let's say one concrete example, it's extracting copper. And this machine is extracting copper, and there's this whole row of diamonds right next to the copper. The machine doesn't care. It has a job, get the copper. But the human person, the human component, the operator who's looking at these cameras will go, those are diamonds, right? So definitely keep the human component involved.
Yes.
That's a great point. Yeah, I think what I'm hearing is the importance of capabilities, really, which is a distinction we make from technologies. In my work with Space Force and other work, I think it's important to talk about these capabilities rather than, what's the widget that does them, or what's the human mind that and fingers that do that. So, great points. Ramon, did you want to jump in on that, or shall we start on the next question with you?
I could just say maybe very quickly to close that the way I see this AI development and additional capability for humans is like there is no lack of problems to solve. We just need to be good at creating more ideas, creating more questions, more challenges, and then I hope AI and robotics will just help us get there faster. So,
I'm going to ask the question that should not be named. Since this is the human, compare and contrast capabilities required for moon missions versus Mars missions and their usefulness on Earth. What is transferable, what's not? And if we've solved for the moon, have we solved for Mars? How does that affect their discussion today?
Mind if I start?
Please.
So it's a little odd for me to be at a Mars conference because I was the Moon Society president for many, many years. So I actually, looking at things, not having an atmosphere creates a whole bunch of challenges, but opportunities. So your problem space between Mars and Moon is a little bit different. In the case of the Moon, we have two major problems: dust, and then surviving the lunar night. Surviving the lunar night means you need to have disconnected power sufficient to be able to survive, but that means now you've got 50% of a given month is unusable. What you really want is dense enough power that you can keep doing what you're doing regardless of whether or not you have access to solar energy coming down. If you solve that on the Moon, it makes doing things on Mars during dust storms a lot easier to do. So they're very synergistic. A lot of the things that, Mars has a lot more water. That's one of the things, even just hydrogen atoms on the Moon is very difficult. So yeah, they're very synergistic. There's, comparing it to Mars, I think Mars obviously is a lot easier, but now you have a very long delay in communications. Mars has to be far more independent. So it's going to be solving problems on Mars that would actually enable for easier robotic applications, other things on the Moon. So yeah, they're back and forth. They're very different, but there's going to be a feedback loop between the two.
Yeah.
So they both enable each other.
Dr. Tiffany?
I don't think I have anything I want to add to that. That was a great answer.
Oh, definitely. No, I mean, I'm just thinking about Ingenuity, the little helicopter, right, on Mars. And that is definitely going to be translated into what we can do here on Earth for sure as we improve the understanding of propeller propulsion systems, right? But Ingenuity, from my understanding, cannot fly on the Moon.
Yep.
No.
Right? So that alone just defines really, or at least answers what you're asking. Can a technology on Mars, for example, be translated to the Moon or reverse? Well, by default, just that one example says not always, but we can learn from it, right? And we can understand it. And just this example alone, with my limited knowledge about how it was engineered to create such a tool, that alone says that we do understand there are differences between atmospheres from one planet to, the moon and beyond. And just the fact that we understand that we are going in from a lens perspective of, as we continue to progress through space, we understand to ask at least several of the right questions. Not all of them, that's part of exploration, right? But at least we can go in there having some foundational question that helps us define what we're trying to achieve.
Yeah. I'm going to do one more question and then our lightning time capsule question, and then we'll get to the audience. So brief answers on this one. How do you see funding for Mars capability development evolving over time? And do you predict a tipping point where everything accelerates? And if so, what drives that tipping point?
So one thing we haven't said yet here is the effect of climate change on market forces and business solutions and kind of where the emphasis is going to be. So, if we see a future within the next few years where, for example, large swaths of human workers can no longer work outdoors, say in India, for example, for large parts of the year because it's too hot, because of extreme heat events. Well, we've already got a problem with our humans on Mars that can't just walk outside and do their jobs, right?
Yeah.
So I see I think of climate change as being a tailwind to drive a lot of what could be happening here in terms of opening up new markets for applications that you can draw a direct line to space. So I would really like, in my mind, if you're solving for space, you're solving for sustainability. If you're solving for sustainability, you have something to add to the space conversation. And I think what the tipping point happens when those pressures really come together in a really amazing way. And that's something that I find great about the Explore Mars community, is because we've got folks coming from both angles and talking to each other. And these types of conversations are the way we get to these tipping points and these sparks. I'm hoping you're going to argue with me. What do you guys think?
I agree, but I think that tipping point, we're in it.
Great.
Given what I see and what's the exchange between those communities and the things that I see in a lot of my portfolio companies, whether they're Earth observation or energy storage, there are applications that are cropping up both from a sustainability standpoint, there's the number of markets where these things are applicable is growing, and space is becoming one of many as a default, not as the exception. So.
I think the tipping point is gonna have to do with humans once they step foot again, first on the moon and next on Mars. I think that there is like so many of the new generations, myself included, have not experienced that moment in history which inspired so many when we first achieved it. So I think in the next years, once that is done, first for the moon and next for Mars, I think that will create really an interest from mainstream, which will make it really that drive back with the strength of the whole world, not just the amazing space industry to really get there and keep going. At the end, it is the next frontier, and we are explorers at heart.
And this is a perfect segue for me to ask my question now that everybody's had a chance to think about it.
Yes.
So everyone in the room that actually really does want to go to Mars, you're actually structuring your life around the eventuality of you individually doing that. Not a preference, but someone's actually planning on doing it. Raise your hands. Okay, we've got about 10. Keep your hands up. How many of you are okay with never coming back? Half, about half. Yeah, okay. Awesome. That is where, and that is fine, because as a business person looking at this room, the number of people in it, that is a market segment. That is an identifiable market segment. We do not have to have everybody on board. What you need is enough people that are willing to do things to be able to buy your product, is how you build this. And that makes me feel good. that's going to be the tipping point, where things fall over in an entirely new state of being that we can't really imagine, is when we have people like that who have left the planet, never intended on return, and that changes the mindset of people on Earth to realize it's not just us now. And so that's the tipping point I'm looking forward to. I hope I'm here when it happens.
Great.
And the democratization of these technologies is going to be huge as stuff gets cheaper and cheaper and cheaper, right?
Yeah.
School kids now can do experiments in space. That's awesome. I actually said that to my 11-year-old son the other day as we were driving home from school, and the look on his face, he was like, why are we not doing that right now? And I was like, we can talk to your teachers, it's fine, like we can make it happen. But again, making it boring is where we're heading, right? This is a market when it's routine. How many of you guys really thought about what was going on in your airplane on the way here? Really thought about it. If you really thought about it, I mean, I try not to think about it, right? Because like, you're in a metal tube flying in the sky. Like, I can go through the Bernoulli principle and the whole thing in my head to like keep myself calm. But it's so boring now. And for me, that's when space is boring, that's when we've done our jobs, right? That's really where it's tipped all the way over.
So that also feeds nicely into my time capsule question. We want to just put this on record. So each of you, 5 words or less. When will humans first set foot on Mars? And from where will they fly?
Can I go last?
Yes. Dr. Ed.
My guess, 2038. And where from? Probably some station orbiting the moon.
(2028) libration window, and from an offshore spaceport. Maybe the next libration window. It really does depend on what happens right now with Starship and its launch dates. And so that's what I'm really paying attention to.
Ramon?
I think I cannot say the same, but I would more or less say the same. I would put 2 more years into Michael's prediction, I think. 2030, I think that would be my pick.
And where from?
From wherever a Starship decides to launch.
That's the question, right?
So I'm also going to say 2028, and I think it is not going to come from a national space agency. I think it's going to be an outside player who's going to get there first.
All right, why don't we have some audience members? If you have questions, there are microphones there, and we're ready to hear your questions.
Clearly, everyone's ready to just go out and start their companies. That's perfect. We're ready for your pitches.
Please.
So if number of launches is no object, what would be the shortest duration for a crewed trip to Mars? I mean, you just gave some very intriguing answers to when we will go and how we would, libration and so on. But if we want to minimize duration of the transit, to minimize radiation exposure during transit, what's the shortest you could compress it if number of launches is no object?
6 months, I believe, right? Between.
It's still going to be somewhat along the lines of where we're at right now, because I think it's far easier to mitigate those issues than try to change propulsion, just because the energy requirements of not just getting up to speed, but then slowing down. I just think it's easier to mitigate the radiation issues with a meter of polyethylene than to try to break our propulsion aspects.
If there was an unlimited number of launches that were occurring, we still have to look at the fact that Mars and the Earth rotate around the sun, and not always at the same speed and pace, if you will. So the optimal time would be when they're closer together, the 2 planets, to reduce the distance in terms of the launches. So, yeah.
Yeah, but the energy capabilities, if we were to get faster, those would have certain business markets here on Earth. Please.
Okay, so I got very curious with like the talk of AI and its role in mining in space, and also of it, like the role of it in mining on Earth. I was wondering if there is like plans to have programs on Earth in countries that have historically relied a lot on mining as a business, if there is like a way to compensate the people who will probably get like be experiencing unemployment because of this in the future, like with education programs or.
Sure, we've actually looked at that. If you look at how Alaska does their permanent fund, realizing that a lot of people are not going to be able to benefit directly from the oil and gas business in Alaska, the state of Alaska collects a certain amount of money from them, and that actually goes into to that fund. In that particular case, they actually write a check if you're an Alaska citizen. In some other countries, they do it slightly differently, and that's sort of a standard kind of thing that exists in a lot of countries that have extractive industries like that. So yeah, I think that's a way we're already doing it, and the more you get into automated, robotic kind of mining, then you'll just use that same mechanism.
Another area you can keep an eye on is cellular agriculture. So that's lab-grown meat, is a short way of saying that. And there are companies like Aleph Farms in Israel who are doing, they have a whole arm of their organization is dedicated to asking the question, what's going to happen to the farmers, right? And what does farming actually look like in a future in which we are able to grow some substantial amount of our food in the lab? You know, I'd made that comment before about tech putting the human back in the medical relationship. You could also see tech being a way to put the human back in the relationship with the land. But that means that the decisions that we make now are going to be very important for how this plays out over the next 20, 50, 100 years on Earth and in space as well. And so I'm glad to hear that these conversations are happening across many of these industries, because otherwise, you know, the techlash that we saw over the last 10 years is going to be nothing compared to what could happen if we're not taking that future forward mindset now.
You know, gamification and AI is a big thing already. We are even training on that this year in terms of having people from different parts of different worlds collaborating as a team to control rovers and drones. And you know, one is a pilot, for example, in a completely different country. Another one is monitoring all the sensors that are being used. This creates more job opportunities. So if you want to work remote or something happens, all you can do is, you know, whatever, even if you have a disability, there's a way to make it work where, you know, maybe you're an amazing gamer. That's a skill, right? So to me, just opportunities are, yeah, abundant.
So imagine Farmville with an actual farm.
Right, Farmville with an actual farm.
I mean, we're already seeing that. It's not just, you know, the cellular-based agriculture. That's actually one of my write-offs was New Age Eats, which was doing a pork product. But you're still seeing the same thing in terms of straight up agriculture technology, removing the farmer from the actual field. It's automated tractors. And I think in the case of Google, they actually have one that goes out and it's a bespoke per plant database. And it treats each individual plant as an individual thing. So it's gardening as opposed to agriculture, but gardening at this tremendous scale. So yeah, it's changing across the board.
Well, we're a little bit over time, but I'm going to let this gentleman ask his question, and we'll have one person respond very briefly, and then we'll finish.
I wanted to ask about boring. You mentioned that's the goal that we want to get to. And as an aerospace engineer, an emergency physician, and as the former risk manager for NASA, I get very scared when business people start talking about making something boring. Most of the US population thought that spaceflight was boring before Columbia broke apart in the way back in 2003. And so when I think about the technical challenges that we're facing and the goals of getting to boring, the 737 MAX issues, right? What happens with industry? What do you see as the role of regulation within these domains to balance this creativity to make sure that boring is not lackadaisical, is not unsafe?
I have so much to say about that personally, but I am the moderator and will withhold.
I'll pass
Please,
it back
Michael.
A good example of that is something called the learning period. and the informed consent regime in the Commercial Space Launch Amendments Act that made a lot of what we're talking about possible in terms of rocket launch. That is due to expire at the end of September. That was there, and especially an informed consent regime, was there to allow people to still do dangerous things. There's going to be parts of what we do that are dangerous, and there are going to be people who want to do the dangerous things even if they know the odds of death are certain. And I think that's something that we still need to allow, and the regulations need to allow that. This is one of the reasons why we lost the aviation industry to overseas for most of the late 70s and 80s. So I think that there's a place for boring. It will get boring one day. Most of us won't be here when that happens, but it will happen one day. I was doing the internet in the 90s, and it wasn't boring. It's kind of getting boring now. So it will happen one day, but it will be really exciting along the way.
Tiffany, Dr. Ed, Michael, Ramon, thank you so much. Appreciate it.
Thank you.
Thank you, everyone.